Chapter 1, Section 2 has a lot of content that you will need throughout the course. However, this is just a short video clip that focuses on setting up algebra problems and tick marks, that is, marking the diagram. Not those kinds of ticks. In this algebra problem, we are given the diagram as shown, that angle ABC is a right angle. That means it's 90 degrees. We're also given angle ABD is 76, 43, 54, and we need to find the measure of DBC. So I'm going to take 90 degrees and then subtract from it 76 degrees, 43 minutes, 54 seconds. I'll think back to what I do for subtraction of a base 10 problem. If I had simply something like 90 minus 76, I have to borrow, because I don't have any ones in the 90 here, I have to borrow from the tens position. Borrow 1 from the tens position. And then I can subtract. You're using a similar algorithm or process here, where I don't have any minutes, so I have to borrow from the degrees. There's 60 minutes in 1 degree. And then I don't have any seconds, so I have to borrow a minute. And there's 60 seconds in 1 minute. So now the problem looks like 89 degrees, 59 minutes, 60 seconds. That's equivalent to a right angle. That's equivalent to 90 degrees. And I want to subtract off 76 degrees, 43 minutes, 54 seconds. 60 minus 54 is 6. 3 from 9 is 6. 4 from 5 is 1. And then 89 minus 76 is 13. So our solution is 13 degrees, 16 minutes, and 6 seconds. Given angle ABE is a straight angle, and the ratio, this is a ratio algebra problem, and these often appear on our assessments. So let's go over this one carefully. Given angle ABE is a straight angle, and we know straight angles measure 180 degrees, the ratio of ABC to CBE is 7 to 11. Now, in all of your word problems, you always need to define the variable. You could do this in a couple of different ways, so I'm going to do this problem twice. So if I do this using a diagram, I'm going to draw out my straight angle. And remember, in this section, we learned that you can't trust the diagram in terms of relative size, but we can assume a straight angle. So if ABC and CBE is in the ratio of 7 to 11, so that means ABC is 7, CBE is 11. There is that parallel structure there. Whatever is first corresponds to that first number, and whatever follows would correspond to the next number. Whenever you see the word ratio, I want you to think x. So that means ABC is 7x, and CBE is 11x. So I'm going to erase all of the extra marks just so you see what I'm looking for when I grade the papers. So I would be looking for the diagram 7x, 11x, and I've defined 7x as ABC, and CBE is 11x. So now we can see 18x, because 7x plus 11x is 18x. would equal a straight angle, which is 180. Might be good to add that definition there so that you're explaining why you're setting it equal to 180. And that means x equals 10. Find the measure of each angle. That would make this 70 degrees and 110 degrees. So now I'm going to redo the problem a slightly different way. Angle ABC is 7x, and angle CBE is 11x. And I'm setting it up and defining my variable in a table here. So then when we add these together, 18x equals 180, x equals 10, that would be 70, 110, and I can double check that that really does equal 180. Either of those, you could set it up this way, or you could set it up this way. But that's what I'm looking for when I'm grading algebra problems. You're defining the variable, and I should have said in here, straight angle is 180 degrees. You're defining your variable, you have your equation, your work, and then your solution. In the diagram above, A, B, C, D, and E, F are congruent. So I'm going to mark them congruent with a tick mark. And as long as the tick mark is identical on all three, then I know the three segments are congruent. So in the diagram below, there are 4 pairs of congruent parts. Can we name them? I see this angle is marked like that. So is this one. So I can say angle GKH is congruent to angle STR. I can also say I don't see another angle with the double arc on it. So I can't say anything about G. I do see this angle here is marked the same as that angle there. So I can say angle ZWX is congruent to angle YXW. And then I noticed that this has 2 tick marks on it, and so does that. So segment ZW is congruent to, make sure that's over the whole thing, segment YX. And then I noticed there's a little V on these 2 parts. You can use anything you want for a tick mark on a segment or for a tick mark in general. So here they're using a letter V or like a caret, as long as it's the same on both of the segment. HG is congruent to RS. Like for grins and giggles, if I wanted to over here, I could have drawn a circle. And that would have been a congruent tick mark as well. Let's look at a few more examples with tick marks. List all given information by the marks on the diagram. Here we are given segment UT is congruent to segment SR. Now remember, the order of the letters doesn't matter, but the mark above the letters does, and the letters must be capital letters. If I would have said UT is equal to SR, that is different. That just means the distance between U and T is equal to the distance between S and R. And we do have an axiom that reads, if segments are congruent, then they have equal measure. But what these tick marks are actually indicating is the congruence. In problem 2 here, we are shown that angle BCE is 90 degrees or right angle. In problem 3, angle BCD is marked congruent to angle BDC. So when you're marking angles, you're using this. In problem 4 here, this is actually getting into chapter 5, but when they put like these arrows in our book or triangles on some worksheets, some other publications, what this is actually showing is that segment or line, in this case EF, is parallel to line GH. In number 5, we are given that segment US is congruent to segment SR and angle TSR is a right angle. In 6 here, we are given that line S is parallel to line T, and then segment DC is perpendicular to line U. So I know that a lot of these markings or concepts of parallel, perpendicular, we haven't gotten to those yet, but I'm just going through what the diagram, different ways it could be marked. Here we have segment VW is congruent to segment WX, and angle VTW is congruent to angle WTX. Here we have angle DEF is congruent to angle CFE, and segment EG is congruent to segment FG. We cannot assume that this is a right angle. We have no way of knowing that. So we can't make that inference. Same here. We don't know that's a right angle either. Discern whether or not the statement given is indicated by the marks on the diagram. So does the diagram tell us that CD is parallel to EF? Yes, it does. It also tells us that DF is congruent to CE. Here we're asked to discern whether VU is perpendicular to RU. I don't see an RU. I think that was supposed to be VT. And no, it's not. So when you put a slash, just like if you had an equal sign, that means equal to, that means not equal to. If you have perpendicular, that means not perpendicular to. And if you have parallel, that means not parallel to. So no, we don't have a way of knowing that VU is perpendicular to VT, but we do see right here that RS is perpendicular to RQ, or that angle SRQ is a right angle. Skipping number 11 because it really goes beyond what our curriculum is at the moment. So at number 12, is HG with the 3 marks congruent to CD with the 3 marks? Yes. But HG is not congruent to GE because this has 3 marks, this has 2. So the markings need to be identical in order to indicate congruence. We do have GE is congruent to ED. We don't know if FE is congruent to anything at this point. Oh, there's a lot in 13. So I'm looking at EF is congruent to FG, angle E, angle ECF is congruent to angle FCG because they both have the double arc, and then angle ECD, that's this one here, is congruent to this angle here, which is DCJ, or I could have also called it GCH. Those are the same set of points. And then I also have segment JH is congruent to segment KD. So is DCE congruent to HCG? Yes. That would be right there. Here we have angle UTV is a right angle. Segment TV is congruent to segment TU, as given by that. Angle TVU, that there, is congruent to angle TUV, and then angle WVU is congruent to angle XUW. The only reason I was tracing over the tick marks is because I wanted to indicate in video which angles I was referring to. So now this is asking, is UQ, I don't even see Q on this diagram, congruent to YP? So I'm going to say no, because I don't even know where those are. List all information given by the marks on the diagram. This mark tells us that angle XWV is a right angle. And notice that it's not an arch, but an actual abrupt right angle. These markings, the little triangles, indicate that line XV is parallel to line UT, and again, parallel is in chapter 5 or 4. And then here, angle UTS is marked congruent to angle UST. And I accidentally traced. You don't want to trace the angle. You want to mark it with the arches. UST. In problem 16, we are given that angle HGE, which could also be written HGD, is congruent to angle CDE. That's here. And CDG is the same set of points. We are given segments GE and DE are congruent. We are also given that angle FED, or angle DEF, is a right angle. At this time, we may not assume GEF is a right angle in a proof problem, but in an algebra problem, I would be fine with that because you know a straight angle is 180 degrees, and then 180 minus 90 would also be 90. So GEF would also have to be 90. But everything that I just talked to would need to be written out in a proof. In an algebra problem, you don't need to be that detailed. Going to skip 17 and move on to 18. Angle, I'm going to put another point on here. AGF is a right angle. Segment GF is congruent to segment DE. Now I said GF, but I wrote FG, and that's okay because that's the same set of points. And then we have angle FED is congruent to angle CDE. And these arrow notations in here indicate, this is getting into chapter 5, that FE, line FE, is parallel to line DC. So even though the lowercase letters, the names of the lines are given that way, in proof, you're going to want to use any 2 points on the line to name the line. It'll just make your life easier. So draw and mark a diagram that contains 2 congruent line segments and 3 congruent angles. So I'm going to ask you to pause the video now and try to do that. So the first thing that came to my mind was a rectangle. Even though we don't have the definition of that yet until chapter 5, it'll just allow me to draw and mark a diagram that contains 2 pairs of congruent line segments and 3 congruent angles. There were a number of different solutions. That is by no means the only one. And then draw and mark a diagram that has 2 perpendicular lines and 4 congruent line segments. Please pause the video and try it again. Remember, you don't have to be able to trust the diagram, but I drew a square. And I'm going to label my points this time. So here I'm going to say AB. Segment AB is perpendicular to segment BC. And 4 congruent line segments. AB is congruent to BC, is congruent to CD, is congruent to DA. So this was the solution, the first solution that I came up with for problem number 20. And I can think of another one. And thankfully, we don't have to be able to trust the diagram. So I'm going to even draw this a little awkward. If I put a point in there, I can mark CD perpendicular to DE. That makes CD perpendicular to DE. And then using my tick marks, I'm going to say that AB is congruent to BC, is congruent to CD, is congruent to DE. So even though they may not always look perfectly equal on the diagram, it doesn't matter. What matters is the tick marks. Thank you. If you found this video helpful, please like and subscribe. Smash that like button. You know you wanna. Come on, give it a thumbs up.